Hello guys, welcome to another stream. Welcome to Caveman Coding. This will be another stream which deals with multi-threading and the select system call in C programming, right? So let's start with the two questions that I have here, which is this. So this will be the first question we will solve. So yep. So let's start reading it. What is the uh, question right here? So in this question, you will write a multi-threaded application to manipulate a single linked list that behaves like a queue. One second. What? Okay. So let's try to break down the question. You will write a multi-threaded application, so which means that you will use p threads, POSIX threads, and to manipulate a singly linked list that behaves like a queue, which basically is a queue implementation through a linked list, right? And each node in queue is basically a first in first out behavior, and each node in the linked list consists of an integer and of course the pointer to the next node. And you will create 5 threads. 3 threads are inserted threads. They accept the name of the file from which to read data, open the file and read the file values in those files, and insert them into the queue. Cool. Assume there's one value per line in the file. That's cool. 2 threads are delete threads, which delete 3 items each from the queue. At the end, after all the threads join the main thread should print the remaining values in the queue to the terminal. Use fgets and scanf to read the data from the file. Also know that you must protect your list when manipulating it. So if you are trying to protect your list, then obviously we need to make a copy of the list uh, before manipulating it, right? So okay, so use fgets and scanf to read the data from the file. So let's try to make a copy of the list. So let's first try to um, let's try 1 second. Let's try to first do the first part of the question, which is implementation of queue. So let's just try to import our, or let's just try to actually like look at the pseudo code basically. So it will be the first step will be um, let's try to break down the question right here. Okay, so break down the question. The first will be multi-threaded application to manipulate the singly linked list that behaves like a queue, which means the first will be create a queue data structure using linked list, using a singly linked list. Cool. That'll be the first task. The second task will be each one of the linked list consists of an integer and of course the pointer to the next one. Okay, you will create 5 threads, which means 3 threads are inserted threads. They accept the name of the file from which to read data, open the file and read the values in those files and insert them into the queue. And then the next step will be the make the p threads inserter 3 inserter and to Yeah, three insert threads access the new file. Two threads are delete threads. So to delete. So using pthread create, I think you can do that. And after that, you need to use insert threads and call the inserter function, the start routine of the pthread of which is associated with the inserter function, which reads the which well what which read the values in those files. So reads the values in those files and insert to queue. That's cool. So and reading is through fgets and scanf. So fgets you will sorry fgets you will use. Damn it! I'm so sorry. How do you even how do you even sonate this? Okay, cool. My bad. Uh, okay, let me. Yeah, okay, good. So we'll use fgets and scanf. So fgets will be used for um, um, opening the file. What is fgets? Let's just figure it out later. But we need to use fgets and scanf. I still do not know what these functions are, but let's use the man page. And the next will be assume there is one value per line in the file. That's okay. Two threads of delete which delete three items each from the queue. So also do the delete function, which deletes three items from the queue. That's cool. Um, at the end, after all the threads join the main thread should print the remaining values in the queue to the terminal. So join it, join the threads, and then print the linked list or queue basically. So yeah, remaining values, and then you must protect your list, which means that the copy after manipulation. Cool. So that'll be it. So let's start by include the statements, the standards std.h standard lib.h standard sys types.h because it's not a socket question, it's just you don't need well, let's just do let's just insert this, but because I don't know, and obviously pthreads.h, and pthread.h. Let me just do this. pthread.h, and then what else? What else do we need though? Insert a function. That's okay. That's all. Delete function. Join the threads. Linked list queue after manipulation. That's cool. I think that's all we need. So let us do the main function. We need the input file name. So we need the input file name, right? So sorry about this. We need the input file name, which is which can be taken from the command line. So that's indog c char pointer argv. Well, if the usage actually will be percentage s the file name to be opened, which contains the values of the linked list. So it'll be argc if it is not equal to 2, you can just print it out into the standard error using standard error, and you can just do usage, the exact same thing. You can just print it out into the std error, and the first argument will be argv0, argv0. Cool. And then just exit 1 1. Cool. That's cool. Now what you can do is basically create a queue data structure using singly linked list. So let's try to do that globally. So struct, let's first make a node, struct node, which will be having int val, an integer value. Is it an integer value? Each node in the linked list consists of an integer and of course the pointer to the next node. Okay, that's cool. So int value, and the pointer to the next node will be the same thing, struct node pointer next, right? And you can just type def this whole struct node to node. Cool. Now after that, after creating a node, now you need to create a queue data structure using a singly linked list. So the queue has a tail and head pointer. So we will do a struct for it, struct queue, which will have a node head and also a node tail. Okay. um, Now you can just type def this again and call it q. Cool. After that, you've defined a q, and then you can define an init function which initializes the queue. Basically, init uh, you can just pass in a queue pointer to the queue struct called this, and you can just initialize the head to null and the tail to null. So that's cool. Now, after doing the queue, um, make the p threads. So inside of function, use the values of and insert to the queue. So we need to, well, define a enqueue function. Uh, enqueue is basically you will insert the value at the tail, right? Insert the value at the tail and remove from the head. So these arguments would be an int val, right? And int val to the queue. So you can just do queue pointer to queue, right? um, so this will be the function, and what will it return? Maybe bool, just so that we know if it is actually returning true or not. So let's just do include std bool dot h. Cool. Now to enqueue, basically you need to insert the basically the tail. So firstly, you need to see if the the tail is you need to see if the tail is null, right? So if the tail is null, that means it is empty. Then obviously, let me just do it here after initializing. So you just check if the tail, you just check if it is null. If it is null, then it's, well, uh, you just point the, well, if it is null, the tail, you just do this, right? Basically inserting at the tail, what happens is actually the tail points to the last node, and the new node will be new nodes next will point to the uh, basically new nodes next will point uh, to the current last node, and you will shift the tail pointer to the new node, basically. So if the tail is only null, then you just uh, point the tail to the new node basically. So before that, you just need to create a new node, which can be done by new node is equal to malloc. You can do a malloc and size of node, right? Size of node. Cool. Now you just do if new node is null, then you just return false. But if it is not, I don't think it is required. It's just the same. Okay, yeah. I mean, it is required. Well, yeah. If it is required. You can just do. Let's just try to implement the case where the tail is not null. And if the tail is not null, then obviously the new node next pointer will be assigned to the queue's tail, right? Um, is that true? Is that right? Let's see. I mean, let's just cross check. Queue's tail will be assigned to new nodes next. Sounds about right. Sounds about right. And then you do the tail. Okay. And then you basically tails. What do you do? And you just basically shift the tail pointer to the new node basically. So what you do is actually uh, queue's tail, put it as new node. Yeah. Also you need to new node val is equal to um, value. I'm sorry, new node's value. Is it values? Let's do value um, equal to val, and new node's next pointer will be the qtail. But we have already done it here. Qtail, the tail will point to the new node, and yep, I think that's it. But if the tail is not there, then if the tail is there, I mean, if the tail is null, which means the tail is not there, then you just do this thing, right? Yep, cool. And then return true. I think that's cool, right? Now let's do q. I mean, sorry, dq, which will return let's just return an int on dq function, which takes in a pointer to queue structure, and also yeah, that's it. Cool. The dq will be basically, oh yeah, If it is null, then you also need to handle the head, because this just means that the queue is empty, and you're doing this, and you can just do queue head also to point to new node, I think. All, is that okay? Not too sure. I mean, it is okay, right? And after allocating the memory to the new node, yeah, okay, true. Okay, then is it really needed though? Let's see about it later again. But DQ is basically removing from the head. So you need to check if the queue's head is null. Then what do? If queue head is null, then you just return. Uh, let's just define. Um, let's just define. Let's just define invalid to int min, which is the minimum number. Um, yep, the minimum number that can that the integer can have. So you just can do invalid, because if we just do is undefined. What do you mean undefined? Is it in? Is it in string.h? Is it in there? It's still undefined. Undefined. Intern is undefined. Is it this? Uh, damn it. What is it? Is it minint? Oh, well, it should be int min. Um, let's just say a high number like 10,000, which means that it is invalid. Okay, cool. Now, if it is not, then obviously you just do else. Well, remove it from the head. What do? Is simply basically from the head. Basically, obviously, you can just do the head pointer points to the first node. Removing it is basically first you just shift the head pointer. You first shift the head pointer, basically q head is equal to q head. How do you shift the head pointer though? the how do you shift the head pointer first? You first shift the head pointer, and then you basically cut off this thing, right? So do you actually use temp though? Do you do a temporary thing? Temporary thing as in you create a node temp and you store the head value there, the head node in there, and when you do that, the temp is containing the head, and then you just there's no previous thing. Oh yeah, okay. The head pointer is here. What do you do in the head pointer case is basically is it actually the tail? Is it correct? Let's just check if it is correct though. Your the new node putting in the Q tail. You're doing Q tail as a new node. I'm sorry. Doing this new node. Next is Q tail. I'm sorry, this is wrong. I always get confused. Represent visualizing the Q. So actually, the head pointer is always in the left, and it goes linearly towards the right to the tail eventually. So when you do tail, the actual tails, the tails next will point to the new node. So Q's tail next will point to the new node, and then after pointing to the new node, you shift the tail. So you do Q tail is equal to new node. Sounds about right. Good. Q tail is equal to new node. Okay. Right. Okay. Uh, Q tail is good new node. That's cool. Now that is cool. Q tail is good new node, and basically if the tail is null, that means the head is also null. The Q is empty. You just put tail as the new node and also the head as the new node. I mean, sounds about right. Removing from the head, what you do is actually removing from the head. What happens is uh, you shift the head pointer to the next node. So which means Q head will be equal to the Q head next pointer, next node, and then after doing that, um, you just after for returning it, you just can create a node pointer temp as malloc size of node size of node. And you can just copy first temp. You can just copy the queue head to this, and then you just do int result to temp value, and you can return the value there, the result there, and then shift this thing queue head to next. Queue head is equal to queue head next, and queue heads to queue head next basically. And you just set the current head pointer. Firstly, I think qx next is equal to null, but I don't think you have to do that. Yeah, and then free temp. But if you dequeue the only head, when there's only one element and that's the head, you have to take care of um, see, I mean, if there's only one element, then what do? The head is, the tail is there only, so there's no next node for it. So what do is basically yeah, you should only do this. Oh, because the you are doing queue to head as temp. So yeah, if temp is null, then null value, there's nothing here, so it will return null, and the head will be pointing to nulls next, which is also null. So queue head will also do null. Okay, that's cool then. Okay, that's cool. But if there are two elements and you remove the head will point to the second node, but also the tail should be there. Uh, like the tail should basically, if queue's head is equal to null, then should also set the tail to null. Yep. Yep. And then return the temp. I mean return result. Okay. Sounds about right. And then so after doing this, make the p threads. So let's just do the p threads. So p threads t will be threads. Let's do inserted threads also. Let's do. Oh no, let's just do threads. Yeah, let's just do threads, and it'll be 5. And because there's 5, and well, and then you do p thread create. You have to do p thread create. But the thing is, dq and nq is okay. You also have to. I don't know why I did dq and nq. Oh, this is the waste. But maybe it helps. Let's see. But p thread create for I end is equal to 0 to I less than 3. 0 1 2 will be the this thing inside the threads. So p thread create. So p thread create again the man function for this. Let's see, manual p thread create. So you just do if this thing is less than 0. Let's just do p error p thread create inserted. And then exit 1. But this should be p thread. The amount of this thing will be threads I. Yep, I. The next argument will be const p thread attribute. So attribute, I think there's nothing, so can be 0. In the start routine, you need to build the start routine. Then obviously you need to define it, void pointer, which returns a void pointer, and inserted function which takes in a void pointer. And so you need to do and inserter and void argument. You can pass in the um, you can pass in I, but it needs to be cast into void pointer. So what you do is actually void convert an integer into point. You need to do int ptrt. So int ptrt, which converts a void pointer to an integer to a void pointer. I'm sorry. I just don't do this. Let's figure it out later. So let's do arg later, and yeah, that's cool. And the same thing which goes in for delete. Just start off with 3, sorry 2, I mean 3. So 3 4 will be the delete function, deleter, and this will be deleter. And let's just do the same thing for deleter function, deleter cool. And I think that's cool. Now after doing that, insert a function reads the values in those files and insert a queue. So before doing that, we need to call in the main function, we need to use the fgets. Is it fgets? Fgets and scanner to read the data from the file. Fgets and scanf to read from file. So what do you do? I think you can just do char file name as argui1, and then how does fgets work? Let's see. It takes in a string and size, so these are most one less than the number of characters specified by size from the given stream. Okay. So file pointer is there. So and stores them in the string str. So it reads and stores them in the string str. And size. Reading stops when new line character is found at the end of error. The new line, if any, is retained. Oh, okay. If any character is read and there is no error, is appended to end the string. Okay. So automatically appended. Zero function appended in the string. Gets function equivalent with an infinite size in the stream. So it returns a pointer to the string. It returns a pointer to the string. Pointer to the string. Get a line from a stream. So 12, if it is that, then it needs a file pointer, and then I think the file pointer is just to you can just do open, I think. Man to open. So you need to include this. Include that. And you wanted to open, right? It gets a file descriptor, unfortunately, so you need to do fopen, which gets you a file pointer. Exactly. So it also gets you a file pointer. This fgets will also get you a file pointer. It gets you a char pointer, which is returns a pointer to the string. Okay, pointer to the string. Okay, good. So you need to open through fopen. So let's just do fopen for that. So fopen, which gives me a file pointer to work with. F open path. So the path will be char point to the path will be just the file name, right? Then the restrict mode, well, the restrict mode, well, in read basically. Okay, nice. You can just do read, I think. R, you can just do R, and the return value will be the file pointer, right? So it will be the file pointer. Must return the file pointer. So let's just do a file pointer file. Let's do input file. Cool. And then if this whole thing gives me, if it is null, then p error, f open, is that okay? So it will be this whole thing if it is null. I mean, I think that's about right, I think. I don't know what's the issue. Let's just do this. I mean, it's cleaner to do this. Cool. Interesting, that's pretty cool. And then after doing that, you need to use fgets. So let's just see fgets man page again. Get a line from machine. So you need to put in a stream. So let's just define a stream, which is, I mean, the string basically, the char let's do buffer pointer, no, I'm sorry, buffer, let's do 1024, and let's do buffer, and size of buffer, well, It attempts to read, right? At most one less than the number of characters specified by size. Okay. So, okay. Uh, okay, that's cool. The size of the stream is actually the file size. So the file size is, how do you get the file size? This is okay. This is input file only. Can you do size of point? The size of a pointer is not really a thing. Can you do that? Apparently you can. And it returns a car pointer, which return a pointer to the string. So it returns a pointer to the string. Basically, returns the buffer, I think, and it stores in the buffer. Right? Okay, cool. Now let's just do if this thing fails, then let's just do p error gets exit 1. Remember which I could have done. I think okay, that's cool. That's anyway, that's okay. And then what is the use of scanf though? Scanf. Mm-hmm. Scanf, scanf, where's scanf? The scanf family of functions scans input according to a format as described below. This format may contain conversion specifiers. The results from such conversions, if any, are stored to the pointer arguments. Okay. The scanf. Um, okay. The scanf function reads input from the standard input stream string. Scanf reads input from the stream pointer stream, and scanf reads input from the character pointed. The scanf function reads input from the standard input stream string. Reads input from the stream pointer stream, and the scanf reads input from the character string pointed to by s. Okay, character string pointed to by s, which is you can just do buffer. Is it? Um, okay. But after getting f gets, you will actually get in the format of like 1, 2, 3, 4, so like that. And now to actually split it, I think you need to use scanf, scanf probably. So scanf, let's do scanf from the buffer. So I need to only use read line by line. So I need to read it line by line, which how is it possible? From the character string pointed to base. So probably I think can you specify the size? Can you uh, you're doing scanf reaches input from the character string pointed to by s. What's the question again? Oh my god. Scanf, I think you can just do until the new line character. How can you do that? Until the new line character. Until the new line character, how can you read until the new line character? Because once you do buffer, it reads in everything. Um, Sorry, what is this? Pointer arguments. The number of input items assigned. So probably, let's just see. You have to do it in the inserter. You have to use scanf here from the buffer. From the buffer, and then that's pretty much it, I think, until the end of line character. So this is the this too few arguments. Probably you need to specify it, right? So assess the okay buffer and should be percentage d. uh, should be val, so int val um, but how do you use scanf though? Let's just see, envision how do you scanf. You just do this, right? Percentage d and store it in here, right? That's what you do. Through pointer arguments. So I think the pointer arguments also you can just do val int result. Let's do int result and show that is it good, is that the case? I'm not too sure, bro. So let me just take a little help from this. How to use scanf. I don't want geeks for geeks. Put line that can be in any of the following formats. There must be space between word 1 and 2. Successfully. Okay. String is basically from that. Read format storage variables cool. You should read formatted data. It works much like scanner, but the data will be read from a string instead of the console. In order to reformat it from string, we must know the syntax of the function. This is the point of the string that is to be read. The function can take in order to show the values. and that is being read from pointer here. If the value is being stored in a regular variable, not a pointer, then the variable name must be okay. There are formats specified according to which the data will be read from the input string. Used to format data being read in a certain way. Reading one item of the same type. Okay. Okay, I think you can have this. That's cool, I think. Reading multiple items of the same type. Uh, okay. Just gonna check it. Mm-hmm. Okay. How to read a space separated two words long string into two separate variables? Damn. How to read just over single data type into an input string? Reading multiple items in different types. Damn. Okay. Nice. I think I've got my answer. Scanf and C. But only reading line by line. I think F gets only you can just do F gets in C line by line. To read a file line by line. 1 second, boys and girls. I'm sorry, I'm back again. Um, if it is right, there is a slash n at the end of the reach line, and the if gets code is below. This is can contain each line must learn the 100. F gets should hit the new line character before. Reach the maximum length, and it should. Stop and return a null. Is that correct? Hmm. Oh, okay. I think this is what we're looking for. F open while f gets. Oh, until the end of the file. Damn, okay. The size of the file pointer, is that right? So I'm just very bad at this. The numbers specified by size from the given stream. Okay, until that it'll read that many characters, it'll read. Okay, until from the stream and stores them in the given string str. Reads of a new character is found, so it will eventually read line by line. Okay, damn. Or at the end of the file, or error. The unit, if any, is written. Right, and there's no error. The pointer to end the string. Okay. Okay, that's cool. Because it will read into a string, because it will append the slash zero, you need to use scan for that. So it will actually read line by line only. F gets, it will read it will actually read line by line. So if it reads line by line, it's not size of input file. Let's just do size of an int, but also +1. So it will actually read the size of int, or plus like at most that. So it will, I'm not too sure. So it'll say until 150 basically. Okay, from the string, and until 150 characters fp I plus plus printf I string. If you want a split value in string, scanf. Oh, from str You're doing str2j, which is the string, and the value. Damn, bruh. Damn. Damn, bruh. Split values basically, and to read file. Okay. Okay, got it. But you're doing while f gets null basically. Then if it actually returns null, um, um, much less than 100, the fk should hit the new line character. Each line is much less than 100 for the maximum, and it should stop and return a null. Is that correct? So it basically reads character by character. Nice. Okay, got it. So you just do while you can just do it is an int, so you can just do long basically until that, at most that, until it will obviously um, hit a hit a basically hit a end of file, I mean end of line character before hitting this is the maximum. So obviously, yeah, I mean, and you basically store it in buffer, right? Yeah, store them in str. So this buffer should actually be um okay, I mean, it can be I though. It can be an integer. I mean, sorry, an array. So it's an array, and you're storing it in there because it is a car. Um, that must be okay. And okay, that's cool. After doing that, after doing that, why is a point? Why is this needed though? I think the line basically, the amount of lines. So okay, so int I equal to 0, I plus plus. You can do scanf right here, Where's it? I don't think this is required. So scanf right here. From buffer %d and store it in result, and this should be maximum lines. So maximum lines, define it here as probably like 10. So you have defined the array. Let's just define it somewhere around here, and you need to put it into reserve I. I think that's cool. Okay. Yeah, and then you can just do, after getting into result of I, pass in result of I here, and then you can insert those things, or it's not needed, you just can result of I, you can use it here. Insert basically result of I, and to convert it into an int though, then it is an int. For int is equal to 0 and less than size of result. But you need to insert, you can just do while result of I to int j, while you can just do is not equal to null, you can just put it, because it is a queue though, and J plus plus. Start from 0. uh, that'll be the head. You can just call in, you can just call in NQ, right? NQ 2 pointer, basically you can have only one queue obviously, so we can just put in like you can just do this and init list. Before the main, I think. And then you can use inserter list. Oh my god. But you need to actually do the list for doing that, so put it somewhere around here only. Right? um, um make it point to this and pointer. You just do that. uh, I think you just do this. Yep. Why is it wrong though? Ideally you just need to do enqueue list and the value from result of j, or actually the insert, and then j plus plus. This is all a mess, man. Oh, I'm sorry if this is not working. Come on now, start working again. Shit. stop working, man. No, I hope that solves the issue. Yeah, it did. I just trying to figure out this. So probably you need to pass in the list. You need to do this though. You actually need to do this and pass in the address to this. That makes sense. So this makes sense, right? It should make sense. Why is it not doing that? Let's just do it in the main function, man. I just want it to be a global, man. So that I can use it directly in these functions in insert a function. Uh, uh, 1 second, I'll be back. I'm back. But what I did actually was, because we have crossed our 1 hour 30 minutes, uh, 1 hour 30 minutes limit. I just gave it to ChatGPT and tried to get the code, and most of the part of the question, most of it, we were going good. So let me just show you the GPT code. Where is my 1000? Same thing. And lock, mute it for thread safety. It is better to use a lock. I did not think of that, but yep. So init and stuff like that, and mutex init, q lock and null. Okay, that's cool. This count is equal to 0. What we did was sign q malloc size of node, new node value is equal to val, new node next is equal to null, lock with after doing lock. If we compare our codes, if we do boolean in q, it's almost the same, but you're actually doing this node pointer. You're or you're actually doing that. I think that's pretty important to do. Um, New node. Yeah, this is actually important though. NQ, new node next is null. But why are we doing new node next as null though? We're just initializing it, and then we're actually doing it right. So, oh yeah, okay, you're NQing at the tail, right? So this is actually good. Okay, that's a good practice. I can see why. Then the p threads and the mutex, well, and then dequeue operation. I mean, this is also okay, but you need to actually node pointer. You need to do this. This is actually needed. Actually needed though. I'm not too sure. Oh, okay. This is actually not needed. Understood. And insert a function. The thing is, you're you're doing this q pointer to storing it here. temp. In this argument only you are passing in the void star and list, because you're doing this you're doing this and you're passing in void star and list. Void star argument you have to pass in, so you are doing void star and list. 1 second. Void star argument. So you're basically doing a void star of and list, passing in the address, and you're doing typecasting into void pointer. Understandable. It's pretty cool. And then you're doing that, and then you're after that you're casting it into q pointer type, and then storing it here into this. Okay, done. Let's counter q for j rest count j plus plus, and then how are you doing the rest count, which is in the rest count. How are you calculating rest count though? Let me just see. You're doing f gets rest count, so and then you're doing s rest count plus plus reading integers from the file, and rest count is less than max lines. You're putting it into res of rest count. Rest count you have put it to 0 first, right? Amazing. So if I could have spent more, probably in half an hour, I would have got this question. But yeah, I've still got a long way to go to actually improve on this. Yep. So after creating, you just do join, that's cool, and then the remaining values in the queue, and then just do this dequeue of list, use an invalid break, printf this thing, printf slash and clean up, do this destroy, return 0. Pretty cool. So that was it for today.